let us see model 3 when two flat plates are connected together. So, as shown in figure. For example, model 3. When two flat plates are connected together. For example, we are having a flat plate with thickness T must be connected to another plate of same thickness, or thickness may change. So, this is our one more plate which is placed on another plate. So, this is the thickness for this section or this plate. This is the thickness T for the above section, where the welding is done here, the plate is here. If I extend like this, the plate is like here, and welding will be done in this side. So, simply we can draw like this: plate 1, plate 2, where welding will be done here, welding will be done here. The top view of this section is in this direction, or as follows, where welding is done here in this portion, where this is known as length L, and welding will be done here, the length is L. So, what is the first step in design process of when two flat plates connected together? As you know, the first step is step 1, size of the plate or flank must be greater than or equal to 3 mm, must be greater than or equal to 3 mm. Step 2, total length, that is equal to L. In that we need to find effective length. Effective length is equal to L minus 2 into S. L minus 2 into S, because we are having two lengths. So, we need to find effective length. Step 3, ultimate shear stress. Ultimate shear stress. It will be given in the question itself. Units are Newton per mm square or Newton per meter square. Step 4, design shear stress. Design shear stress, that is F suffix WD is equal to, Fu by root 3 into partial safety factor. Units are Newton per mm square. Step 5, design strength in the weld, that is equal to PD is equal to 0.7 into size of the weld into L effective length into design shear stress, that is FWD, that is design strength in the weld. Units are kilonewtons or newtons. The last step in this particular case, we need to find the design tensile stress of the flat. So, the last step, that is step 6 is equal to step 6, design, this is tensile stress in the flats. The design tensile stress or design tensile strength, sorry, it is not stress, it is strength in the flat is T D is equal to 2 times of design strength in the weld PD by area of the plate, that is B into T. So, this is a design process when the two plates or two flats connected together by using a gusset plate overlap. When the two plates are overlap and fillet type weld is done, we need to follow these types of steps for design procedure. The first step is the size of the flat, that is S must be greater than or equal to 3 mm. It is common for all the design methods. Step 2, where we need to find effective length, that is L effective, total length minus 2 times of the size of the weld. Step 3, ultimate shear stress is equal to, it will be given in the question itself, units on Newton per mm square. We need to find design shear stress, FWD is equal to the ultimate shear stress by root 3 into partial safety factor, where partial safety factor will be given in the question based upon the type of the weld. If the weld is done in the workshop, it is 1.25. If the weld is done in the site, it is 1.50. The fifth step is the design strength in the weld, PD is equal to 0.7 into size of the weld into effective length into design shear stress. So, in this particular case, we need to find design tensile strength of the plates or flats. So, the new formula is the design tensile strength of the flat TDB, it is denoted with T suffix D is equal to 2 times of the design strength of the weld divided by area of the plates. So, in this particular case, we need to find or we need to derive the design tensile strength of the flats.